Hi, I am Neev of grade 10 from Ananketan Maninagar campus. Today I am going to explain how aerodynamics works with the help of paper airplanes. We are going to see how these paper airplanes are connected to the designs of automobiles and real life airplanes. To start with aerodynamics, let us first take the plane. This is the dart. When air passes through it, this surface bends, making the tail surface grow downwards and the nose surface go upwards. This helps this plane to fly. The problem with this plane is that it can only travel as much as your strength can muster until gravity takes it down. There are four forces acting on it. The first one is drag. Drag is the sum of all air molecules resist on an object in motion. The second one is thrust, which is the energy that pushes it forward. The third is gravity, which pulls everything towards the earth, and the fourth is lift, which opposes gravity. The airflow over the wing ends up getting pushed downwards. The downward force pushes the wing upward, which results in lift. All this happens due to the Coanda effect and Newton's third law of motion. When all these forces are balanced, we have flight. If we decrease drag, it will reduce the energy needed to move forward. This is the reason why airplanes have pointy nose and automobiles have windshields which are pushed backwards. Flight of dart. We can solve this problem if we decrease the drag and increase the lift. So this is the phoenix, which has bigger lift area due to the center of gravity pushed a little forward. As the center of gravity is more forward, it will point down, which allows it to get speed lost from drag. When it gains speed, the air deflects off from the surface to push the plane down and the nose up. The problem with this plane is that it cannot handle the speed at which we throw it, and it will come back like this. We can overcome this problem by building something that can handle this thrust. So this is the super canard. It has the center of gravity at the center of lift, right at this point. Stall is the best thing about this plane is that it is stall resistant. Stall is caused when there is low speed or when the angle of incidence is too high, like this. When air passes through it, the front wing stalls first, which drops the nose down, and the main wing keeps flying, which results in stall resistance. The problem with this plane is that it cannot handle too much drag. This is the flight of super canard. This is a Suzanne. It can handle the thrust and is slippery and air. In this plane, the angle between these wings is very important to be 155 degrees. It is important because at this angle, Coanda effect and Reynolds number work together to give the perfect lift. This is the flight of Suzanne. This creates smooth airflow. Coanda effect states that airflow will follow the shape of whatever it encounters, and Reynolds number is a dimensional number used in fluid mechanics to indicate whether fluid flow past a body or in a duct is steady or turbulent. In this plane, the center of gravity is forward. As the center of gravity is forward, the upper wing lifts the nose. The upper wing lifts the nose, making it giving it the perfect flight. And this plane will fly the most if we measure the distances compared to other planes.